what I was mentioning is a lot has been spoken and a lot of facts have been presented with respect to where we are in terms of limitations, what are the opportunities, what are the numbers, and the way forward. I would like to spin the discussion towards basically three buckets. When we talk of energy transition, grid stability is just one of the pillar, an important pillar. But energy transition is far beyond the grid. Focusing here on the grid, we would put, I would limit here to the three sections. One is what are the technological bottlenecks? Okay, the basic premise is there are bottlenecks in terms of grid stability when we move from traditional to the transition energy or the new source of energy. So I'm limiting this bottlenecks to one is technological bottlenecks. The second is execution bottlenecks. And third is the global or geopolitical bottlenecks. I think we have had sufficient discussions. So I would be little crisp in terms of technological. One of the challenge that has been spoken by earlier speakers as well is the location of these wind farms, solar farms, and is far little than the consumption point. And while it creates the connectivity challenges, it also creates technical challenges in terms of voltage stability and drops. And of course, the excess is challenging. So that's the technological limitation. The another technological limitation we are talking about is the reliability, both in terms of solar and reliability. When I say it is not only the reliability in terms of availability, but also in terms of the fluctuations that we see from a minute to other minute or from an hour to another hour. And that is still creating a lot of challenge in terms of utilizing. The other speakers have also spoken with respect to standard assets. The third limitation here in terms of technology is basically the inertia. These renewables, as compared to the fossil or traditional source of energy transferred to the grid, there is a huge imbalance in terms of inertia, and that need to be addressed very finely. And at this point of time, we are technologically limited in terms of giving a stable grid, balancing this inertia issues. The second issue, what we were talking about, the executional challenges. Of course, my other colleagues have already talked about the transmission versus generation gaps, both in terms of the execution timelines as well as execution complexities. Many times the 12 months that my other colleague mentioned for the building up of a solar park or wind farm is not enough to get even the right of the way for the transmission lines. And we have seen it again and again. The projects are stranded, and we are having even everything goes wrong, the transmission lines takes far longer, both in terms of the cost as well as in terms of the execution challenges technologically. So that's a very relevant thing, and I unfortunately do not see any way out in the immediate future. It will take time before we can really say that these things are balancing. The thought that I have is we really need to balance both in terms, when we talk of transmission, transmission has to go with more blending from solar, wind in the equal measure with like nuclear or hydro, which are again long gestation periods. And that's how we need to have perhaps two-pronged strategy. One is short term, another is long term. For the short term, we need to go on the solar wind, focusing on a very small catchment area and small distribution area. For the interstate or long distances, we need to focus on hydro and nuclear. The third dimension that I want to put here is the geopolitical risk. Now, while it is good and it is necessary perhaps or at least it is fashionable to mention that we are onto the energy transition. What we are ignoring is the geopolitical risk. We are facing a very, very uncertain world where things are changing rapidly from moment to moment in the dimensions and in the directions that we have little influence on. As I mentioned, we are active in terms of energy transition far beyond the grid stability, so we face it day in and day out. We talk of energy transition, but we forget that whether it is hydrogen, so we need electrolyzers, whether it is even the solar or the wind, we need to have the wafers and the panels and the magnets. All these things are, India is heavily dependent on, as a nation, we are heavily dependent on the overseas suppliers. Now, one can argue that so is the case with coal and, not coal, with oil and gas. But at least those sources are distributed, and as we have seen in the recent conflicts, there is a possibility of expanding your portfolio. Whereas when we talk of the rare earth, or we talk of the semiconductors, or we talk of electrolyzers, there is virtually kind of, if not monopoly, oligopoly. So when we are navigating those kind of geopolitical uncertainties, we have to see how do we balance energy transition without risking the grid is just one part of it, but on a larger context, even the availability. So here, I would say this is where I would put a stop on the bottlenecks. Now, having said that these are the bottlenecks, what is the way forward? And what do I see it in terms of next steps? Are we going to just sit on the bottlenecks and wait for some miracle to happen? No. There are issues that are being addressed and can be addressed. I'll start with the green hydrogen mission. Government of India has rightly pushed it. I think it insulates us very well in spite of the economic challenges, in spite of the technological challenges. It is far, far more almost independent in terms of the generation. Economics is the challenge, the metallurgy is a challenge, but we are clearly seeing that this will happen the way it happened in case of solar or wind. The economics will fall in place, and the kind of investment that we are talking, the kind of actions that we are seeing even on the ground, the green hydrogen is here to contribute much more significantly than what we have anticipated, and much more faster. So that's one dimension where I'm quite optimistic. I'm quite bullish that that will be something which will help us in terms of energy transition or grid stabilization. Energy transition primarily, and even grid stabilization. When we are talking of triple digits of gigawatts of the factories, we are virtually creating parallel grids, and those grids will be designed. Unlike one of the challenges that we are facing in the grid today is these grids, the current installed grids are one way. Whereas with the push up of rooftop solar and those kind of things, we are also facing the challenges in terms of having adjust to the bi-directional. Won't go into the details because the amount is very, very insignificant as of now. But yeah, it is enough to create the ripples on the grid. But when we are talking to the green hydrogen or large parks, I think the grids design will take care of this challenge that we are facing today. The next technology which we are seeing is like we are talking of now. Okay, the capex are the challenge. Still, technology is little limited, but technology is there and it is proven. When we are talking of grid forming inverters, so that is another area. I would those who belong to my generation would be able to recollect 30 years back what was the kind of inverters at homes. I am seeing now these inverters being installed in the distribution centers, in the generation centers. It will of that size. It will be there if we have any logic or any sense to move in terms of fossil or traditional source to the renewable sources. And the last point is what we are talking in terms of the risk. Now, yes, I mentioned about the hydro, I mentioned about the nuclear. Both of them are what is necessary in terms of energy transition, but comes with a huge risk. The hydro comes with a lot of executional risk, a lot of environmental risk, and a lot of, I would say, even humanitarian risk. The nuclear comes with, of course, the industrial risk as well as the humanitarian risk. So what is needed is, I'm still very hopeful. One of my colleague previously mentioned about the example of the France. We have seen the examples of Germany. We have seen the example even in the United States. The nuclear will be far more reliable because I think we are quite strong in terms of the technological stability in terms of nuclear technology as compared to the hydro, which is quite dependent on the nature and quite dependent on the geology rather than geography. So with this, I would, I think I was given 10 minutes. I have exceeded that time. But with this, I would like to pause here and give you a one-liner. I am quite confident that energy transition will take place. I am equally confident that it will not take place in the manner that we envisage today, because what we are ignoring is we believe we are on our own and we can do whatever we need to do or whatever we like to do, forgetting that we are a part of the connected world. And whatever happens or whatever in the neighborhood or within the different states, we are a federal country. So these things have to synchronize the way we want to synchronize the grid. We need to synchronize the policies, and we need to have that kind of understanding with multiple players to see that it takes place in a manner we desire to take place. Thank you very much.